Welcome to Hope Academy. My name is Mr. O, and today I'm going to be explaining a little bit around the confidence interval concept and go into depth around the procedure for hypothesis testing when it comes to the confidence interval. So today in front of you is a question that I'm providing that I found online that sort of helps deliver that sort of purpose behind it. And so I'm going to go ahead and read the question. David, a starting player for a major college basketball team, made only 40% of his free throws last season. During the summer, he worked on developing a softer shot in the hope of improving his free throw accuracy. In the first 8 games of the season, David made 25 free throws in 40 attempts. Let P be his probability of making each free throw he shoots this season. And so, based on this question that is provided, there are a few things, key informations that I noticed, and I'm going to go ahead and underline them. So right here, it says 40% of his free throws he made last season, and it also mentions that in his first 8 games this season, he made 25 out of 40 attempts. And so the purpose of today is to prove whether or not from his prior performance of 40% of making his 40% of his free throws, that whether or not this statement 25 out of his 40 attempts actually proves or points out that he actually improved in his free throws or whether or not. And when we are doing hypothesis testing, it's based on a procedural step-by-step process. Depending on the question, it might be 4 steps, sometimes it's 5 steps. Some people, they even sometimes break it down to 6 steps. But the point is that it's dependent on how many steps you need in order to prove it. But I will explain to you for specifically confidence intervals what you need to know. Before I do so, I know that right off, because they gave me the population sort of value, I know that this is going to be a proportions sort of z test. So it's not going to be a t-test because I know the population amount of free throws, which will eventually help me find variation. And so since I know variation, it has to be a z-test, not a t-test to start off with. But as I'm talking about this, it is definitely a confidence interval based question, and I'm going to be using this as my proportion value. So step 1. Step 1, the purpose of step 1 is to identify my null and alternative hypothesis. For this question, I do want to mention that my P, as mentioned, is his true proportion of free throws made. And so for specifically this one is the last season. And so last season he made 40% of them. But when we come to our alternative hypothesis and our null and alternative hypotheses, we do want to test whether or not his 40% actually improved or not. And so in our statement for step 1, we're going to say whether or not P is equal to 0.40. And the reason why I state that is because our end goal is to prove that alternative hypothesis is true, or that we could reject null hypothesis. And so alternative hypothesis is whether or not his free throws actually improved. And so that means that the proportion amount actually increased, and thus P is greater than 0.40. And that will conclude my first step for this question. Afterwards, as the procedure goes on, step 2 is usually what I call the conditions. The specific rules or, set of rules or conditions that need to be fulfilled before I could even do this whole test. And so the first thing in the condition for specifically confidence intervals is always going to be the SRS, which is the simple random sample. It's sort of the acronym for it. And for this question, it's not really mentioned whether or not they randomly sampled it or whatever not. But that being stated, we could assume that this is fulfilled. So we're going to check that off. The next part is that whether it is normal. And the way we test for normalcy for this type of question, the way this actually works is that we're going to state NP is greater than or equal to 10, and N1 minus P, and duly note this is actually going to be the P hat value, which is greater than or equal to 10. And when you're wondering, what is my P hat value? This 25 out of 40 actually is my P hat value. And 40 is going to be my N value. So technically this portion right here is technically going to be written out as 40 times 25 out of 40 is greater than 10. And technically 25 is greater than 10 because the 40s cancel out, and thus why I have 25. Here, same thing, is 1 minus p, so technically be 40 times 15 over 40 because the gap between 25 and 40 is a 15 gap, which is greater than or equal to 10. And I know that because these cancel out, 15 is greater than or equal to 10. And I know that these two conditions do get fulfilled because I could write it out there. You don't necessarily have to on the examination, but as long as you mention it or you even write this down, it's better to err on the safe side for the AP Statistics examination. And so that's how you're going to go about doing so. Aside from these, the last condition you do want to mention is not always necessary, but always just write it down. SRS usually entails some independence behind it, but you do want to mention independent. And since it's SRS, we could assume that one variable does not affect the other variable, or aka one of his free throws will not affect the next performance of his free throw. And so that concludes the specific steps I did want to mention for step 2. Step 3. On the AP exam, they do like it if you identify what type of test this is. So this was going to be a 1 proportion Z interval, because we're actually, for this question and because for the condition around this video, I do want to make it a specifically interval based question. And so what I did was I identified it as a 1 proportion Z interval. That's what I'm going to start off with. You don't need to necessarily write this down. You could actually do is also write down the equation. So p hat plus or minus z star, or aka the critical value of z, square root of p hat 1 minus p hat over n. A lot of times this equation, and this is more for the purpose for you guys to see, this equation usually is written in this format too, p hat q hat over n. So p hat q hat is going to be your 1 minus p, aka your complementary value that we are talking about. And so that concludes sort of my step 3, sort of writing it out. And this will eventually tell me my confidence interval, and I'll explain what that confidence interval means. So I'm going to go ahead and plug in values. So when we are plugging in the star, or aka the critical value, it's important for us to know that the z star value will always be, if it's not mentioned up in the question right here, and if you notice they didn't give us aka what an alpha value is or significance value is, usually you're going to assume if it's not mentioned that it's going to be 0.05 or aka 95% significance. And so for this question, for the most common value for z star is that 0.05, and this is something I memorized. I will teach in another video around how to read the z chart or z flow chart, as some people call it, the t chart. But for the conditions around this, if it's 90%, and I'm going to write it here in the corner, you do not need to write this in the exam. It's going to be 1.645, and for 95%, it's going to be 1.96. And so for this question, I'm going to do the 95%, so 1.96. And so I'm going to go ahead and get started. So for my p hat, it's actually going to be 25 out of 40, because that is my sample size, plus or minus a 1.96. 25 out of 40, 1 minus 25 out of 40 over 40. And I'm going to go ahead and calculate that, the stuff out. Personally, for me, when I'm doing this computation, I'm not very keen on fraction values. And so I have the inclination to create these into decimal formats. You could do whatever you prefer. I think that to err on the safe side, it is preferable just to use the calculator, which is allowed on the exam, and to use that calculator and change them to decimal values, which is perfectly fine to do. So I'm going to change 25 over 40 to 0.625 just to start with. And I'm going to take things step by step, 1.96, and I'm going to take care of the inside here first. A lot of times people sometimes punch in values and mess up the values a little bit. So you do want to take things step by step when you're computing these things out. So 0.625 times 1 minus 0.625, enter, and then divided by 40. That's going to be the value without the square roots. So make sure I'm going to square root that value, and I'm going to put the answer into here. And that is my value that I'm going to use. It is 0.07654. So I don't need to use as many decimal placements, all the decimal placements. I could go up to like 3 or 4. I usually err on the 4th one just out of accuracy purposes. And so since I am doing this based on the accuracy purposes, I'm going to go ahead and write that down right now. it's going to be 1.96 times, and I'm going to put a dot here, it's going to be times 0.0765, and I'm going to stop right there. Okay, now I'm going to clean up things a little bit, so I'm going to, with my handy dandy calculator, once again, continue it on, and I'm going to clear the screen just to help myself out and not get myself confused. 0.0765. Okay, so I get right here 0.625 plus or minus 0.1499. Okay, I'm going to stop there. And so I'm now going to create the interval that exists because the plus or minus lets me know that. 0.625 minus 0.1499, 0.625 plus 0.1499, and I get two distinct values right here. It's either between 0.4751 comma 0.7749. Okay, and now for specific confidence intervals, it's usually only up to step 4, so I'm going to write step 4 here. Step 4 usually is my conclusion, explaining what does that mean. What does this value 0.4751 to 0.7749 means? Well, if we want to relate it back to the original question and what we are looking at, his original rates of success was 40%, as it was mentioned. This preseason, or aka the last season performance, was 40%. And now if we, after his coaching and all his, extra practices and whatever not he's been doing, this is stating that with 95% confidence, we can state that this interval that we have captures the true population proportion of all free throws that he made this season. And so that means that this season, this is his accuracy. Since 0.04, as we mentioned before, was his original one last season, and now it's now higher than that. It's not even including 0.40. That means that he actually improved quite a bit. That means that he actually improved, and that this practice or coaching or whatever he's been doing has been impactful towards his performance. And thus, this is how we're going to explain it. So based on the sample of David's free throws this season, we are 95% confident that the interval, and duly note, I am writing a little bit small just because of space reasons, but you get the idea. It's that when I'm writing this out, 4751, comma 0.7749, the important thing is that when I'm writing this out, I am very thorough and detailed about what my final conclusion is from this study. On the AP Statistics examination, they do want you to write as much detail as possible. It has to be correct detail, but as long as you provide detail, even if it's a little bit on the excessive side, it's better for you to do that in order to get the full points on the examination. And so that's why I'm writing this all out. Because 40%, and I'm going to continue on, because 40% is not included in the, and I'm going to use a new paper just because I'm running out of space, in the interval, it is likely, just like thinking how to phrase this, is likely that David did improve. David improved in his free throws. Okay, and so that concludes sort of the explanation, the procedure, step-by-step process in order to do the hypothesis test for this. But I do also want to provide you understanding around the calculator. So on this examination, especially on the free response portion for the AP Statistics examination, the part about this is that you could actually use the calculator to help you. And so let's say that all this computation and whatever not aside, that you're wondering if I actually computed this right. Like I might have messed up on this thing, and I want to use this as like a double check sort of system. You do have to write this stuff down on paper, but on the calculator, it also provides you the option to do this. So I'm going to push stats right here, stat, and I'm going to move it up just to show one more time, stat right here, stat. And I'm going to click the left arrow key to test. You could do right key, but make sure you're getting to test right here. And I'm going to scroll down and look for Z interval. And so because usually on your calculator, it's going to start off with data, which we're not using data because we're not actually given like his specific performance things. We're just given specific numbers. We could use this sort of, values that are provided right here. But because this is not, there's a z interval value, you could use that, or because this is actually a proportions test, I do want to point that out, we're going to use the one proportion z interval test. I just wanted to point out that you might get confused and push z interval first, but it's actually going to be one proportion z interval, which is right here. And so I have old values put in here, so I'm going to change that out. I am going to plug in his test proportion, or aka his sample proportion of his throws, which is 25 out of 40. And so on the calculator, I'm going to type 25 out of 40, and I'm going to calculate that. And if you look right here, and I'm going to compare it to my answers I wrote right here, this is 0.47497, this one says 0.4751, which is reasonable because there's a round off error that could exist, to 0.77503, which is another round off error potential. This shows that this could be like a double check system for you just to make sure you are correct. So that concludes my explanations for today. Just in case you want to see this, I'm putting it here. Feel free to like our channel, or subscribe to our channel, or like our Facebook page. I'll be continuing to make more videos around this for the FASTREV, or aka Fast Review, on these topics. Please feel free to leave a comment below if there's anything else you want me to cover, and I hope to see you next time.